So today we will be talking about something that is called as classification.
Okay.
So what happens is, um, for example, you have a raw satellite imagery. Okay.
Mm-hmm.
So now you want to turn this raw imagery into a thematic class. What it means is, uh, for example, this is your river.
Mm-hmm.
This is your built up area, houses or something, right?
Mm-hmm.
This is vegetation here. So now you want to do some analysis and you want to understand that in my image, what is the number of pixels of water? Number of pixels of water. What is the number of pixels of this building area, right?
Mm-hmm.
Similarly, what is the number of pixels of this vegetative area? So once you have a pixel wise density, that is the count, then you can say, right, that 30% of my, that is like whatever the number of, for example, if for vegetation, whatever the number of pixels it is, X by the total pixels, total pixels in this image into 100. So it is the percentage of this pixels in the overall image, right?
Mm-hmm.
So you can simply say, for example, if it comes out to be maybe 30%, so you can say that 30% area in my image constitutes of vegetation, right?
Yes.
Mhm. So what if there is something in the image that you don't know what it is?
Mm-hmm.
What then? Okay. So I broadly classified it into vegetation, water, or buildings. There is
Yes.
something in the ground that you do not identify. You don't
Clouds.
know what it is, right?
Mm-hmm.
Maybe, for example, let us say this much area. It is something you are unable to understand in imagery, or it is something new other than these three, right?
Mm-hmm.
So now it becomes an unidentified class. What it means is, if you understand the meaning, so this is
Yes.
one class of pixels. Class means that they have been classified into one category. This
Mm-hmm.
is vegetation, this is water, this is buildings. So similarly, whatever this is, it is that only, whatever it is, right? Unknown thing.
Mm-hmm.
So basically, if you take a satellite image, now first of all, there is two things. One is depending on you, and other is depending on the computer.
Yes.
Now, if you tell the computer, I have this image, convert, classify this image into 8 classes. So it will try to find out pixels that are looking alike and
Hmm.
find 8 different classes.
Yes.
Maybe inside of water only it finds out 2 classes. One is maybe deep water. So this is deep water maybe. So the
Hmm.
pixels here they look alike. One is maybe not so deep water. So the pixels here look alike. So it
Hmm.
forms 2 classes here itself. One here, one here. Got it?
Yes.
So a class is defined as a combination of pixels. It can be anything. A combination of pixels which are alike in nature. Okay.
Hmm.
Now, just a moment. Mhm. Okay. Now you told the computer, you defined it 8. Okay. What if I told the computer to do it? Define the classes by itself. So the computer will apply algorithms inside of it. It will see which is better and it defines maybe 5 classes. It says it is better to make 5 classes rather than 8. Okay.
Hmm.
So it defines 5 different classes of pixels. Now, why it is why do we do classification in the first place? Okay.
Hmm.
So it is for the better analysis of your data. You have a satellite imagery. Okay. Maybe this is forest, small patch of vegetation. This is small patch of vegetation. They're not together, but they are the same thing, right? This is small patch of forest. This is one house. This is one house here, right? So maybe this is your study area, okay?
Hmm.
Or maybe this image is whole your study area. Now you want to understand like what percentage, for example, you are working with maybe some urban development company. They tell you find me out the percentage of buildings, flats, houses here. So what you can do? You can only calculate the pixels, and based on that pixels you will calculate the total area, right?
Yes.
Because they are scattered. Maybe you have an image, you have a very big image. There are 1 lakh houses at different places. One is here, one is here, one is here. So, can you manually calculate the area of each house? 1 lakh houses.
No.
So, what you will do is you will use something called as classification.
Hmm.
So, what classification will do is it will create a class of pixels. What it means is because the pixels in this, in this, and this are similar, it will create one class in which there will be the total of these number of pixels because they are alike,
Hmm.
right?
Yes.
So if I now say, tell me how much percentage is the building class in this image. So it will be the total number of these pixels, right?
Hmm.
Now, classification has been basically divided into two things. So the first thing is information class. Now, what is a information class? What it means is this is more about the terminology here. Now, if you have a image, you know there is this river, and you classify these class of pixels as water
Hmm.
because you have prior knowledge of it that this is water, this is river, this is maybe buildings. So it is a class specified by an image analyst. That means class, you named this class, right? You called it as water because you know this is water. So all the
Hmm.
pixels in this class are defined as water. That is given by you. So in that case, it is called as information class when given by a image analyst or any person. Okay.
Hmm.
But what if I give that image to the machine? Now computer does not know what is water, what is what. He can only just classify that these pixels are looking alike. They may be something,
Hmm.
right? So
Yes.
if I have an image, maybe other than river, maybe uh, this is something here. So the computer tells me all the pixels in this region, or maybe you can add a small region here also. So all the pixels in this region and this region, they are looking alike. They are very similar to each other. I am computer. I don't know what it is, but I am telling you they are looking very similar. It can be called as one class, like a single class. You can call it a class or anything, but it they are like one entity. Got it?
Yes.
Mm. Now, how the computer defines it, why, how it is looking alike, what computer means is, so if you remember, so if you remember from this one lecture here, so there is this brightness value, right? So
Hmm.
everything forms a curve. Okay.
Yes.
Now, what happens is, just consider this here. Let me call it red band. So across the imagery, so I have an image. I take out the red band image from it. So it will be a combination of three bands, right? The image.
Yes. Red, green.
It can be RGB, it can be anything. So just let us consider maybe I say it was an RGB image.
Hmm.
I take out the red band from it. Now
Yes.
the red band is gray shade, right?
Yes.
So based on the red band, every point on the image, every point on the image has a reflection value of it. So
Yes.
if it is ground, so red band, it struck the ground and it came back. So it has a value for every point, right?
Yes. Yes.
So somewhere it is bright, somewhere it is very bright, somewhere where it is not so bright.
Hmm.
Okay.
Yes.
So based on the brightness level. So if I put uh, just a moment, if I put yes. So instead of wavelength, now if I'm having this axis, X and Y, I put here the brightness of the pixel in the red band, right?
Hmm.
But because this is an X and Y axis, to plot I need X as well as Y, right?
Yes.
So maybe let me take one another band. Maybe can take any, can take blue, can take green. Maybe I take blue band. So I take the image of blue band and the brightness in blue band, I put it along this side.
Okay.
Now for every point on this image,
Hmm.
we can say it has a brightness value of for red and as well as blue, right?
Yes.
So let me take the X value as the brightness value of red and Y
Hmm.
value as the brightness value of Y.
Yes.
So I can plot the brightness value of each point. Each point on this image can be
Hmm.
plotted in this X and Y.
Yes.
Okay.
Hmm.
So I plot this. So the ones that are close by, they form one class and the others form another class, right?
Hmm.
Now I can
Yes.
say the image can be classified into three classes. Maybe if
Yes.
I want more classes, I can apply some different algorithm and I can say maybe I have six classes. So
Hmm.
number of classes depends on us, what algorithm we apply, but we
Yes.
can define the image into many
Classes.
classes and we can put it into X and Y to understand better.
Yes.
Now, if for an area you have maybe sentinel imagery, you have band 1 to 13, right? So you can
Hmm.
use any two bands here and create a graph like this. So this graph is called feature class graph. Feature class graph. Okay.
Hmm.
So by definition, it is a class, spectral class. It is a class which includes similar gray level vectors in the multispectral space. Spectral classes are groups of pixels that are uniform or near similar with respect to their brightness values. So I made the classes right.
Hmm.
I did not know in the image what it is because I am the computer. I can just make the class right.
Yes.
You have to tell me whether it was water, whether it was land. But I made the number of classes as may you wanted. If you want 10 classes, I can produce 10 classes. Okay.
Mm-hmm.
So in that case, it is called as a spectral class.
Okay.
So one is a information class, one is a spectral class.
Okay. Mm-hmm.
Now there is this another thing, uh, the same thing only, but in another words.
Mm-hmm.
So we understood when the computer is doing it by self, it by own self, it is called as spectral class, and when we do it, it is called as information class. So
Yes.
broadly, we have new two terms that is called as supervised and
Supervised.
unsupervised.
Unsupervised. Yes.
Uh, Just a moment, I'll get a glass of water, okay?
Okay.
Now, what is happening is what supervised actually means, what unsupervised actually means. So you already have an idea what it means by the terms information class and spectral class.
Yes.
So if I have an image, I have this river. What I do is I pick some pixels from it, some pixels.
Mm-hmm.
It is called as sampling. So
Yes.
I pick some pixels from all over the uh, river area because I know it is river, right?
Mm-hmm.
Because I am the image analyst, I know it is river.
Mm-hmm.
So based on my judgment, I say I take some sample pixels. So it can be maybe 10 pixels inside of this, maybe 1000 pixels inside of it. But I take some sample pixels and I tell the computer that this is water.
Mm-hmm.
And I take some sample pixels from here and I tell the computer this is buildings.
Yes.
Then I take another sample from here and I tell the computer this is vegetation. So maybe here is also vegetation. So wherever it is.
Mm. Just a moment.
Yeah.
Well, this one. Yeah.
Okay. Just a minute. So you told the computer that
Mm-hmm.
this is water, this is building, this is this,
Mm-hmm.
this is this. So it is on you. the number of classes you can identify, right?
Yes.
So once you identify a certain number of classes and you tell the computer now to classify this image. So
Hmm.
you did some training samples. These samples are called as training samples.
Hmm.
So what training sample means is the places where you are sure that it is something that you are telling the computer.
Hmm.
If you tell the computer this is water, so it will take the pixels from that and it will analyze the brightness values, right?
Yes.
So if you remember the graph that it creates, this is one band.
Hmm.
It can be red, anything. This is band 2.
Yes.
Now, once you sample it, it will put based on the values of brightness in these two bands, it will
Hmm.
give it a position here, maybe here, right?
Hmm.
So now you can understand that all the pixels that will be in this area that will have values at this and maybe there is another cluster formed of pixels. This is another cluster.
Hmm.
This is another cluster.
Hmm.
So because you defined it already, you told the computer, now you
Hmm.
easily know because some of them you picked up. Now, because of your an input, we know that all the pixels here are water.
Yes.
All the pixels here are building.
Hmm.
All the pixels here are vegetation.
Hmm.
Now you have clear classes. So you trained some of the pixels, but because of those some pixels, you are getting all of your pixels clustered in a place, and now you know that these all are water.
Hmm.
Now the computer, after this processing, it will produce an image, a thematic image,
Hmm.
where it will say, it will give the symbology as you wanted. Maybe it will make the color blue. You have to give the input of the color. So all the
Hmm.
pixels here will become blue. So maybe somewhere here is also water that is very similar to this. It will also become blue. Any pixel that was similar to your training sample will become blue.
Hmm. So is this pixel-based classification or object-based?
That is, this is pixel based. So we don't talk about object based in, how to say, like it is something that will come deep down in the classes. It is not for now, but it is pixel based. Okay.
Okay. Okay.
So you have an image that is created. Now it will give all the pixels that look like water blue, all
Hmm.
the pixels that look like vegetation, maybe vegetation. You can say all the pixels that are vegetation. It will make them red. So you
Hmm.
will get a image out of it.
Yes.
But here you already gave the input. So that is why you know it was water, you know it was building, you know it was vegetation.
Hmm.
Now, what if you did not give any input? You did not select any training sample. You did not select any sample and you told computer to do the work. I am not doing anything. Computer, please, you do the work. Okay.
Hmm. Hmm.
Then the computer says, uh, then the computer says, let me classify. And how does computer do it? Because there is no sampling, computer directly performs this step. So computer creates two bands, that is band, it takes any one band and then it takes any other band. So the pixels having alike values, they will still form clusters like this, right? Right?
Yes. Mm.
Hmm. So computer says this is one cluster, this is another cluster, this is another cluster. I don't know what it is. I'm just giving you the result that there are three classes in this image. Define for yourself. If you want to call A vegetation, it's on you. Call it vegetation. If you want to call this buildings, call it buildings. It is on you. I'm just giving you the image where I have classified the pixels that look alike into one. I don't know what it is. Okay.
Mm.
So basically here in supervised, the result is more accurate. Why? Because you know what that is on ground, right?
Yes.
Whereas in unsupervised, you get a result. Maybe sometimes you have to do unsupervised classification because the maybe the field area is not uh, like it is not accessible or you cannot actually do the field there. It is maybe risky. There are snakes or something, right?
Mm.
So in that case, you will do unsupervised classification and you will get the thematic map. Okay.
Then what is ground truth points? We go manually on the ground first.
So ground truth point is that didn't we discuss it in the drone classes in GCPs? GCPs?
I guess it's in the supervisor as well.
No, but did we discuss the?
But we don't have a drone class.
Okay. So
Mm.
basically, ground truth point is like you did sampling here, right?
Yes.
You gave the pixels, you called it water. So
Mm.
you know what the truth of the ground is. You know, in the ground it is water.
Mm. But we don't go and sample first and then with the imagery we do give the points. So I just
So
forget the name of the device. Spectrum something.
no, no, no. So what happens is in supervised you are giving training samples, right?
Okay.
So how do you know it is water?
Because of the colors and the brightness value
Okay.
reflectance. Mm.
So maybe you have to perform supervised classification and there is something on the ground, you don't know what it is. So what you
Mm.
will do? You will go on the ground, right?
Okay. And
And you will
okay.
check what it is. Maybe it was a sandstone or maybe it
Mm.
was uh, a well, right?
Mm. Mm-hmm.
So you will give it a you will give a training sample here and you will call you because you have to do field verification. That is the ground to thing.
Mm-hmm.
So you call it a well.
Okay.
Now there is this one terminology when you take training sample because in this training sample it captures the sample pixels that have the most probable brightness values of your defined area, right?
Mm-hmm.
So we also call it as signature of the class. Those brightness values are of the also called as signature of the class. So this is like the signature of this class, that in this graph it falls here. This is the signature of buildings. The signature of vegetation is that it falls here. Okay.
Mm-hmm.
So it is also the terminology that is used is the signature.
Okay.
Okay.
But usually ground truthing is used in drone mapping.
Just a moment, let us confirm.
Yeah. I guess I forget the device name. It shows the reflectance value. Spectroscopy. That's
Spectrometer.
spectrometer, I think so. It's kind of a camera which gives the reflectance
So it is
value.
just going on the ground and checking what it is actually on the ground. So as I told you, maybe it was a well. So in satellite
Mhm.
imagery, you could not understand what it is. You went to the ground and you said, okay, to better understand this, you can understand it like this. What ground truthing means is that, so this is your field area. This is all agriculture land. All of it is agriculture land. Okay.
Mm.
So you have some parcels of field. Now I tell you that in this rice is grown, in this corn is grown. Okay. Find out what is, now I'm telling you that in this area, total area, only rice and corn are grown. So
Mm.
find out what is grown here, 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 what is grown here. So what you will do is you will go to the ground, you will
Oh, check the whether
you will
this.
take some sample pixels here,
Mm.
that is and you will see, okay, in the ground you will verify, okay, it was rice. Maybe you take some one more field area, you went here also and you saw, okay, it was rice. You took some sample signature from here also. Now you took some for corn, and then when you applied this to this image, the classification, it will tell you where it is. Maybe this all was rice, this all is corn, this all is rice. Based
Mm.
on the sample from here, it will tell you about all the image. So that is called as ground truthing. Got it?
Yes.
So computer system must be trained to recognize patterns in image data. Process
Mm.
of defining the criteria by which these patterns are recognized. Supervised training is controlled by the analyst. He selects the pixel that represent patterns, instructs the computer to identify pixels with similar characteristics. More accurate but requires higher skill. Then then we have the unsupervised. It is computer automated. Specify the number of class and the computer will create the statistical classes itself, right? Less
Yes.
accurate but requires less skill.
Mm.
So in supervised classification, uh, you take your imagery, And if some processing is required, you can do that, maybe atmospheric correction or anything. After that, you collect. So pre-processing means maybe you want to classify using false color image or RGB or maybe any combination of three images, right? So that is the part of pre-processing. So once you have the image, you take the sample signature. So you take pixels that this is water, this is something, and the computer evaluates and creates a classified imagery. Got it?
Yes.
Now there are some algorithms in both supervised and unsupervised. So there are two kind of uh, algorithms that we used just in supervised. That is called parametric decision rules, and another one is called
Non-parametric.
non-parametric decision rule. So it is very important to remember these terms, that is minimum distance, maximum likelihood, parallelopiped. There is maybe some error here. It is O. So parallelopiped feature space classifier.
Mm.
Uh, what parametric decision rule here means is that in parametric one, we apply some mathematical operations, whereas in non-parametrical, there is no mathematical operations. It is more based on the geometry. Okay.
Okay. Okay.
Now, if you talk about the minimum distance classifier, what is in supervised, what is minimum distance classifier? So, as I told you, if we take two bands on axis, that is band 1 and band 2, it can be anything, right?
Mm.
So, once we do that, we are able to get clusters of the pixels that look alike. And because this is supervised classification, you already told the computer, okay, this is water, this is urban, this is something, right?
Yes.
So after you start the processing, there will be a graph created like this. Now there is a pixel in the image which the computer has to decide it will fall among which of these three pixels. Shall I call it water? Shall I call it urban? Or shall I call it vegetation?
Mm.
So this is the cluster, this is another cluster, and this is one another cluster. But the pixel we are talking about is here. So its brightness values are this and this. So it is very different from these three, right? You cannot directly say it is this or this or this, right?
Mm.
So, but you have to, at the end, you need to classify it. Okay. So
Yes.
you will apply some kind of algorithm to classify it. So in that
Mm.
case, first we talk about the minimum distance classifier. What it means is, so these points, if the mean of these points is here and the mean of these points falls here. So at the mean of these points, taking the mean of these points and its distance from the unknown pixel, whichever is at the shortest distance,
Mm.
it will become that class.
Okay.
So in here, if you see, it looks like it will become urban class, right?
Mm,
So it will obviously become urban. Now there is this one thing. It assigns the pixel to the category with the shortest distance, right?
mm,
But it can also assign the pixel as unknown if you have given a threshold input. What threshold means is that you input something inside the computer that you say if the distance of any pixel, it should be at least 10 meters.
mm.
Maybe if you say maybe the distance should be whatever this is 10 units, okay? So what if this is at 11 units? So if this is at 11 units and this is obviously more than 11, this is more than 11, this is more than 11, right?
Mm,
But you defined that it will only be given a class if it is at least 10 units. So now this time it will not be given a class.
mm,
Got it? Because you defined a threshold. If it
mm.
was 9, if this was 9, it would be said to be urban signature. Got the point?
Yes. What do you mean by units? It's like the spec.
Units means because this is the brightness values, right? So
Yes.
if there is 2 points,
Mm,
so I can easily find out the distance between them, that is x2 minus x1 plus y2 minus y1 square
mm,
underscore or something. Uh, Distance between 2 points on XY graph. So this is under root x2 minus
mm.
x1. So if I have 2 points, I can easily find out the distance between them. Got it?
Yes.
But because this is brightness values, there can't be any meter, centimeter or something. It is just distance between them. So I will
Ah,
just call it units.
okay. Yes.
Variance coordinates. So the one formula that I just showed you, this one,
Yes.
if you do by this method, it is called Euclidean distance. It is based on the Pythagoras theorem, right?
Yes.
But if there is another method also that is called as Mahalanobis distance,
Mm,
so it has something here that is includes the variance,
mm,
covariance.
yes.
And do not need to understand the mathematics, but it will be rarely used. Just understand the concept, how minimum distance works, right? And
Mm,
in most cases, you are working with Euclidean distance only. Okay.
mhm.
Then after minimum distance, there is this another type of supervised classification. It is called as maximum likelihood. So, have you done these in your classes in Austria?
I guess we have like tourists, but don't have this theory.
Okay.
In I guess advanced or something class, they just tell the classification. That's it.
Okay.
So first.
Okay. Anyways, let's take a 5 minute break, huh?
Okay.
Okay. Hello.
Yeah.
Okay. Um, just a moment. Okay. So what happens is in maximum likelihood classifier, it
Mm.
is a little complicated than the minimum distance.
Mm.
Uh, so you remember that we create a X and Y band 1 and
Right.
band 2.
Yes.
So what happens is when it forms a cluster, right? So if this is a class, what variance word means is variance is the spread of individual features, right? That is, for example, this pixel value is here and this pixel value is here. So the variance is a measure of kind of the spread, how the each pixel in this class
Mm.
is different from each other to the way the extent is different. For example, maybe if you go by this, that is in band 1, the lowest brightness at this point is maybe 10. The highest brightness can be 40. Similarly, it has a brightness value in this also,
Mm.
right?
Mm.
So maybe this all look kind of similar in the image. Maybe they all look green or the shades of green, or maybe the it is, it is basically the spread of those pixels. Okay.
Mm.
So it can be defined mathematically. It is called as variance.
Mm. Yes.
Then there is something else that is called as covariance. It means the directional relationship between two features. Now, what directional relationship means is, for example, this is the mean of this class.
Mm.
I'm uh, may- okay. I'm just trying to first explain by the mean by the way of class, but you can also do it on the pixel level. So
Okay.
maybe this is another class. It has a mean here.
Mm.
Now you can define two vectors, one from 0 to the mean, and this is and the other vector is this one. So this vector is the mean vector, right? So
Yes.
if you see there is a directional difference in them.
Mm.
So that directional difference can be mathematically calculated and it can be taken into covariance matrix. So it is deep mathematics. Don't need to worry about it. Just understand that there is something called as maximum likelihood classifier and
Mm.
it works on the variance and covariance
Yes.
of the elements. Okay.
Okay.
Now what happens is uh, if I try to explain it very mathematically, so this was one class
Mm.
and this is another class.
Mm.
So if I define vectors to every point, for example, if I say vector to each and every pixel, similarly, vector here to each and every pixel. Either you can use this one or you can use directly the mean vector that is to the center of it. So at the center, it means it is 100% probability that the pixel is maybe water, right?
Mm.
As you go away from the pixel center, as you go away from the pixel center,
Mm.
the probability decreases that it can be water or it can be another class. Maybe
Yes.
the probability here is that it is 90% water
Mm.
or 10% it can be vegetation,
Mm.
right?
Mm.
So there will form some circles like this.
Mm.
So a probabilistic distribution curves appeared, right?
Yes.
So maybe if I have a new point now and the point is here, okay? So
Mm.
based on these probabilistic circles, there must be a probability of it, right? That
Yes.
it is more probable that it can be water,
Mm.
less probable it can be vegetation.
Mm. Yes.
So based on the probability, it is assigned a pixel.
Mm.
Got it?
Yes.
So if you see now, you have three different center of means, that is here, here, and here. So this one is of urban, this one is of
Vegetation.
vegetation maybe,
Mm.
and this is of water.
Okay.
So
Yes.
this circles are called as probability contours. Okay.
Mhm.
Now, if I place a point here, based on the curve, it has a probability. If this also creates a circle here, the intersection would have common probability, right?
Mhm.
So it states maybe it is 90% probable to be this. So every point can be, if I take any point, it can be assigned to the, based on the probability, it can be assigned a class, right?
Yes.
Mm.
So what about like the far away, like uh that point? Wait.
So
The,
you have to give a
like
threshold that
this.
outside this distance, you will give
Mm.
a threshold that may be outside this distance from the center of means. If it is so away from it, then maybe do not assign it a class.
Like
Otherwise, the best probability that will fit it will take the class.
mm, same like the minimum classifier likelihood
Yeah,
classifier.
yeah, very similar.
Okay.
So now there is non-parametric decision rule.
Mm.
So in non-parametric, you have parallelopiped
Mm.
and you have feature
Mm.
space classifier.
Mm.
So this time you're not taking two bands, you take three bands. Band 1, band 3, and band 2. Got it?
Okay.
Now the distribution will be 3D.
Mm-hmm.
So for example, one of my pixel falls here and the last one falls here. I can kind of create a cube rectangle over it, right?
Mm.
To the extent my pixels are present, I can create a surface, right?
Mm.
Now, if there is an unknown pixel and that falls inside my, maybe if I'm going to define a new pixel here, so it falls inside this box, I will readily say it is vegetation, right?
Mm.
So, if it is outside the box, then we will use, then I don't think so, we will classify it, okay?
Okay.
So it will kind of create a box.
Okay.
Now, similarly, since here you created a regular surface, what
Mm.
if your data was if you moved according to the data, not moved regularly? What it means is, for example, you moved here, you created this box, then you came here, but then
Mm.
the next pixel you saw was here, and you reduced the box size, you cut it. according to the data. What it means is,
Mm.
if you try to understand it in 2D, so you take the actual values only. You don't create a regular box.
Ah, yes.
So previously I had a point here, I had a point here, I had a point here, I had a point here.
Mm.
Here, 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 here. But when I use parallelopipe, I choose when I will go here and see, I will go like this, go like this. It will be more uniform,
Mm.
right?
Mm.
But if it is feature space, I will
Mm.
directly connect to my points.
More
Got
like
it?
object based.
Yeah, can say so.
Mm.
Then after supervised classification, there is unsupervised classification. In unsupervised classification, you have
6.
uh, 6 different types of methods, but in
Mm.
GIS, we discuss only 2 types. So the rest
Mm.
of 4 is for you to do extra study if you want to. Okay.
Okay.
We only do k-means and isodata. This is the most common used ones.
Okay.
It is so rare that I have never heard of any other terms other than these two.
Okay.
Okay. So in unsupervised data, we do not have any initial idea of what the class belongs to. We just
Yes.
tell the computer to find it. Okay.
Yes.
Then the computer tries to spectrally separate the pixels. User has controls over initial cluster values. You can define the number of classes, but you
Mm.
cannot do anything else than it, right?
Yes.
So then there is something called as number of iterations.
Mm.
What happens is, uh, how I will try to explain this is, so I had the band 1, I had the band 2. For example, you will give an input to the computer that you can only define a class only when there are maybe you can only define a class when maybe it includes at least 30 pixels.
Mm.
Got it?
Mm.
So maybe if the computer made a class here and it had more than 30 pixels, and you defined another class here, it had also more than 30 pixels. So you were able to define a class. But these points here are 28. Okay. So because they are 28, you cannot define a class because this is the rule that you have set. Okay. So now
Yes.
the computer will try to break this because the function has not finished yet. So it has to
Mm.
iterate. Iterate means it will keep on going on. So it will keep going on until it classifies it into one class, maybe this into one class. Because you only said that the number of classes here can be two only.
Yes.
Maybe if it was three or four, so but because these were not the number of pixels that you wanted, so it had to break it up. Got it?
Mm. Yes.
So this is called as this is simply how unsupervised works, right?
Yeah. Mm.
Now, if you see this, if it this was an image, you applied the unsupervised algorithm, it
Mm.
kind of said based on the pixel values, it says maybe this is class C. It is unsupervised, and you get a final supervised image, right?
Yes. Yes.
Unsupervised image, sorry.
Yes.
Now, because we just discussed two types, that is k-means and isodata, so
Mm.
they work on a very similar kind of behavior, not behavior, but they work on a similar kind of algorithm.
Mm-hmm.
So what happens is, uh, in general, both methods assign first arbitrary initial cluster values. So you made clusters, right? This is
Mm.
class 1, this is class 2. Initially, some cluster was made.
Mm.
It is still processing, but initial cluster is made. Okay.
Mm.
The second step classifies each pixels to the closest cluster. Now, for example,
Mm.
this is a pixel because it is near to this one. This class will grow.
Mm.
So if it was
Maybe
near
like
to,
minimum clustering.
yeah, first it will do minimum clustering. After that, it will, for example, if number of 30 pixels were required to create a cluster, it
Mm.
first created a cluster. Now
Mm.
there are leftover pixels. Now
Mm.
the computer will work on that.
Mm.
Okay.
Mm.
So in the third step, the new cluster mean vectors are calculated based in the third step, the new cluster mean vectors are calculated based on all the pixels in. So once the final cluster is created, once the final cluster is created, maybe this is the final cluster. This is the final cluster. So the mean vector is calculated from the center. This vector is calculated. There is a length of it, right? It has
Mm.
a direction to it also. So this will keep on happening until uh, what it means is, so if there are some more pixels, this is not actually the final, but it is growing to be the final one. So
mm,
this is happening at every step. So once it grows into such a value that the next time the mean is created at the next step, there is not much difference in the mean. It is very similar to the previous one. That is,
mm.
the change in the mean starts to be very small. Got it?
Yes.
Okay. Now, this is how k-means work. Okay.
Mm,
But the isodata algorithm has some further refinements by splitting and merging of clusters. Now, there is no splitting and merging of clusters in k-means.
mm.
Once the cluster is formed, it will stop there.
Yes.
But in isodata, what will happen is, so if you remember, uh, we just did a little mistake in understanding the concept. That is, for example, just go a little rewind. When
Mm.
the initial cluster was made, okay, when
Yes.
clustering starts, there cannot be a threshold because it will start from like it will start from 0, 5, 10, right?
Mm.
Okay. So
Mm.
in K means there is nothing as a threshold. But in
Okay.
isodata, there is something as threshold.
Okay.
So in K means what will happen? The cluster will grow. Wherever
Okay.
the computer has thought of it, it will grow. And
Okay.
at one time, once the mean starts to not change, it will stop there.
Okay.
But in isodata, what will happen? Once it achieves this position, now
Mm.
it will look for any cluster that is not following the threshold value.
Okay.
For example, this cluster has
Mm.
less than 30 pixels.
Yes.
So this is not following the rule of threshold.
Mm.
In K means there is nothing like this. It will stop. This is your
Yes.
final result. Got it?
Yes.
In ISO, it will do what? It will break this and split it and merge it into another
Ah,
class.
okay. Okay.
Got it?
Okay. Yes.
So the threshold, so the threshold is done. So there is
Mm.
also this given that clusters are split into two different clusters if the clustered standard deviation exceeds a predefined value and the number of members pixels in twice the threshold for the minimum number of members. So it is mathematical, right?
Mm.
So there is a rule about something about standard deviation that it should be less than, then it will split, right? So got the rule. The threshold is not directly the threshold. It is based on the standard deviation.
Mm.
Okay.
Yes.
What it means is this figure 30, this there will come out a figure, a value that if greater than that value, it will not break. If less than that value, it will break. That
Mm.
figure will come out as a result of this line. That is, if the cluster, this cluster, if you try to find the standard deviation
Mm.
and it exceeds a predefined value and the number of members is twice the threshold for the minimum number of members,
Mm.
right?
Mm.
Just understand that this is something mathematical. Don't worry about how it works.
Mm.
You know now the logic, right?
Yes.
So it is very difficult to kind of do it in QGIS, but it is very easy to do in softwares like
Yes.
Irdas, ArcGIS.
Okay.
It has been quite a time, even I am out of touch, but let us look for it and do it in ArcGIS.
Okay.
So maybe let me add an image. Four, three, two. Which one did we just add? 432. Okay. So I added the red, green, blue of Sentinel image, right?
Okay. Yeah.
Hmm. This is L2. Okay, 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 okay. Yeah, this is Sentinel. But now maybe there is something called as layer stack. If it is available here, so we will use the tool that is composite bands. Creates a single data raster from multiple bands. So here
Okay.
we will select these three, 2, 3, and 4.
But why we have to do this first?
Because this is a gray scale imagery and
Hmm.
it will be very difficult for you to look what it is. You don't know what is this is. So you don't know what this is. You will get a better idea in either a true color image or a false color
For
image. So maybe just let me make it 432. Or maybe 234 is better. So let us see what comes out. So if you see, I have created a true color image. So select it. So if I do band 3 to 1, I get a true color image. Got it? You can also see maybe some factory or forest fire. Just imagine the scale of it. You can see it from satellite. Okay. Now, I go to the classification wizard and I select the method. There are two methods, that is supervised and unsupervised.
Yes.
So, just the basic difference between object based is and pixel based is pixel based works on every pixel, pixel by pixel,
Mm.
pixel by pixel, right?
Mm.
Whereas in object based is it will create a cluster beforehand. It will say, okay, there is this group of
See,
pixels
very.
that are similar. So it will
Mm.
ta- just in a manner to understand theory, it will call it a big pixel, a big object.
Mm.
So it will take that object as one pixel. Got it?
Yes.
Instead doing 1,000 pixels, it will make it one pixel. I'm s-
Mm.
technically I'm wrong, but I'm theoretically trying to explain what I mean. Okay.
Mm.
So it
Yes.
will be one object.
Mm.
So either you can select pixel based. So pixel based is time taking, object based is not time taking.
Okay.
Okay. So there is this training samples. Let us first do unsupervised. A schema is that it will be used for the training. The schema is the legend that will be used for classification. The classification schema will be used in the training sample page to set the that will be. Maybe let us just try. I think I need a classification schema. Okay. Let us first do supervised one. Let us first try supervised one. Okay.
Mm.
So if I go to classification tool, here you will find something called as training samples manager. Once you click it, you will see different classifications. You can create a class of your own also. So
Yes.
uh, there must be an option here, create new schema. That is, if you want to add one more or delete it, right? So you can,
Mm-hmm.
for example, now I know this is water, right? I will just click
Mm-hmm.
on water, select the rectangle. So this has taken some sample pixels that all of them are water. So
Mm-hmm.
this is also water, right?
Mm-hmm.
So I've taken two. Now maybe I look for a developed area. Okay.
Mm-hmm.
So this looks like developed area, right?
Yes.
So I've taken four samples of developed area.
Mm-hmm.
Then there is barren land. So this looks like barren land.
Mm-hmm.
Then there is forest. So this either can be shrub land or anything. Maybe let us just call it forest. I won't create shrubland herbivorous, not even wetland. I'm happy with all these four classes, okay? So I will save this in my computer and maybe to downloads, demo schema, save. Now the schema is saved. Now this time if I apply the classification wizard, so if I choose the supervised, I can simply go to my demo schema saved as a shape file.
Because you select as a feature class. Feature type of feature class.
Mm. I think I need to look into it how it will work. Reference data set was composite band and It should show up here, right? Demo schema. So I will look into it, how it works. But you understand, right? It is somewhere here only.
Hmm.
It so both maybe we will do this both next time. How
Okay.
supervised works, how unsupervised works, and we will do
Hmm.
a sample of it. Okay.
Okay.
So in today's class, other than this, if you have any doubt,
No, no. I will again go through it again.
okay. Uh, do you need the images?
But just one thing, like if I do supervised or unsupervised classification, for example, in e-cognition as well,
Mm-hmm.
then we have like a random forest classifier and MSV
No,
something
that
like
is not classification. That is not supervised and supervised classification. That is
okay.
segmentation.
Okay. So what is the difference between them? Segmentation and classification.
Mm.
Segmentation like pigs breaking the pixel and
So this is a image
oh yeah, yeah, got it. Like it will
mm,
create a one
object, like a one
yeah
big
object.
pixel.
Yes. It depends how much size I want, and then it cuts into this. Yes,
Yeah, yeah.
got it.
So what it means is like, for example, when you are doing unsupervised classification and you are taking objects-based image analysis.
Hmm.
So as I told you, K means ISO data, right? So there are other methods also. There is SVM, there are n number of methods. So you
Okay.
can apply any one of it. But don't worry, once we get to recognition, we'll also try to understand it. Okay.
Okay.
Okay, then we end today's session here,
Okay.
and I will see you on Thursday.
Thursday or Friday?
Sorry, right. Actually, I wanted to say, is it possible to on Sunday? Actually, I'm a little busy.
Hmm.
Is it possible to have a class on Friday and Saturday?
No,
Or
no, I guess
maybe,
we have. Oh, sorry. We have a Thursday class as well because last time we changed the schedule. Sorry. It's
okay,
on Thursday as well. From 10 to 1 or 10 to 12, up to you.
okay. Then we will
Same time.
have the class on Thursday. That is 2:30 for me, right?
Yes, and 10 for me.
Okay.
Yes.
Then I will see you on Thursday.
Perfect. See you.
Oh,
Bye.
bye.